Shielded arc welding is usually accomplished by means of an electric arc formed between the work and a coated metallic electrode. Let's see what happens. When the arc is struck, it almost instantly creates a temperature of about 6,500 degrees Fahrenheit. This melts both the base metal and the metal in the electrode. The metal from the electrode is melted off in tiny droplets, is carried across the arc and mixed with the molten base metal. The force of the arc and the forward travel of the electrode causes the mixed molten metal to be pushed to the rear of the crater, where it cools to form a bead. The movement of this metal toward the rear of the crater and the depth of the crater are an excellent check on the quality of the work. The operator should learn to use it as his guide. At the same time that the metal is melting, the coating on the electrode is being consumed. This takes place slower than the melting of the electrode, which shields the arc and helps direct the flow of metal. It also permits the use of higher currents, with the resultant faster deposit of weld metal. A gas is formed, covering the arc with a protective shield that prevents the exposure of the molten metal to the air and therefore prevents the formation of harmful oxides and nitrides in the deposit. Also from the coating, chemicals acting as cleansing agents enter into the metal to help to remove the impurities. These chemicals with the impurities float to the top and, cooling, form a coating or slag over the bead. This slag causes the molten metal to cool more slowly and has an annealing effect.